This is chapter 7, day 2 for Algebra 2. We are going to start by adding and subtracting radicals. So you can only add and subtract radicals that have the same index and the same radicand. So they have to have the same little number outside and the same number on the inside. We're just going to look at some of these for time's sake. So looking at number 2, I have a 54, a 2, and a negative 16 radicand. So I currently cannot add those together. So I would simplify them first. So starting with 54, I would come up with something that goes into 54. So I'm going to go 6 and 9. I know that 6 is 2 and 3. 9 is 3 and 3. So remember, this is a cube root, so I'm looking for groups of 3. So I can bring out a 3. This 2 is stuck. So 3 times 3, we've got 9, cube root of 2. The next one is a 2 on the inside. We can't do anything with that. So minus 2, cube root of 2. Then plus, oops, I can see actually now it's actually going to turn to a negative in a second. I've got the cube root of a negative, which I know is a negative, plus 16 can go 4 and 4. Those go 2 and 2. So I'm looking for groups of 3. So here's 3 2s. To bring out a 2, and this 2 is stuck. So then outside, negative 2 times 7 would be negative 14, cube root of 2. So now I can see these are all cube roots of 2. So I can put them together for some amount of cube root of 2. So 9 minus 2 would be 7, minus 14 is negative 7, cube root of 2. So it's just like when you do something like 2x plus 3x, you end up with 5x. That x stays x because that's what you have. It's an unknown x. You had 2 of them, you had 3 of them, so now you had 5 of those x's. Same thing here. The radical will stay the same, and you work with the numbers in front. All right, so on this next one, we've got 10 radical 28. So 28 I know can go 4 and 7. I know the square root of 4 is 2. 7 is stuck. So 10 times 2 would be 20, square root of 7. Then the cube root of a negative is a negative. 56, I can go 7 and 8. I know the cube root of 8 is 2. 7 is stuck. So I've got minus 2, cube root of 7. Now I've got 175. So let's see, 175, I'm going to do 25. So I've got 25 and 7. I know the square root of 25 is 5. 7 would be stuck. So 5 times 4, I have minus 20, square root of 7. So now I can see the radicand of all of them is 7. However, the middle guy is a cube root, so I can only put these two together. So 20 radical 7 minus 20 radical 7 would actually cancel out, and I'm just left with negative 2, cube root of 7. So that's how you add and subtract radicals. You can only add and subtract like radicals. All right, so let's move on to multiplying. So when you multiply, what you do is you multiply the outsides, you multiply the insides, and then you simplify. So looking at number 8, on the outside, 3 times negative 2 is negative 6. Square root of, on the inside, 10 times 18 is 180. Then I would simplify it like I'm used to. So I'm going to go, let's see, 9 and 20. I went 9 and 20 because I know the square root of 9 is 3. So then 20, I'm going to go 4 and 5. So I know the square root of 4 is 2. And then 5 is prime, so he's stuck. So on the outside, 3 times 2 is 6, times negative 6 is negative 36. Square root of stuck inside would be 5. So looking at number 10, multiply the outside. Negative 3 times negative would be positive 3. Cube root of 64 times 8 is 512. So now I'm going to break that down. So 512. Well, honestly, I'm going to just take it right back to 64 and 8. I know that 64, I can go 8 and 8. I'm looking for groups of 4. That's only 3 and 8, so I can go 4 and 2. Still don't have any groups of 4, but I can to take my 4s into 2 and 2s. So then we need 4 in a group to go outside. So here are 1, 2, 3, 4 2s to bring out a 2. And then there's 1, 2, 3, 4 2s to bring out a second 2. And then this 2 is stuck. So on the outside, 3 times 2 is 6, times 2 is 12. 4th root of inside we have 2. So you multiply the outsides, you multiply the insides, and then you simplify. All right, so going to the other side, keeps jumping. There we go. We're going to throw some variables in. So we can see on number 12, we don't have anything on the outside. So cube root of multiplying the inside, 54 times 5 is 270. M to the 8th times m to the 4th would be m to the 12th, because when you multiply like bases, you add the exponents. 270, I'm going to go 27 and 10, because then I know the cube root of 27 is 3. 10 would be stuck. There's not going to be any groups of 3 and 10. M to the 12th, I could make 4 groups of 3, so that's m to the 4th. So outside, I have 3m to the 4th, cube root of just 10 inside. All right, number 14. Outside, 2 times 7 is 14. 4th root of p squared times p to the 3rd is p to the 5th. Q times q to the 10th is q to the 11th. So I'm making groups of 4 this time. So if I have 5 p's, I can make one group of 4. I'd have 1 left over. If I have 11 q's, I can make 2 groups, which would be 8. And then so I have 3 leftover q's. So outside, I have 14 p q squared, 4th root of inside p q cubed. All right, now we're going to look at some binomials, 2 terms. So let's actually go to number 15 here. Same concepts. You multiply the outsides, you multiply the inside. So when we take through radical 10 to 5 radical 5, we have 5 on the outside. Radical inside, 10 times 5, the insiders would be 50. Minus radical 10 times 2 radical 2, we've got the negative 2 on the outside. Inside, 10 times 2 would be 20. Then we would have to get it in simplest form. So 50, I can go 5 and 10. 10 is 5 and 2. Right, so couples go out, singles stay in. Bringing out the 5, trapping the 2. So 5 times 5 is 25, radical 2, minus 20. I'm going to, I put it in the wrong place, wrong color. 20, I'm going to go 4 and 5, because then the square root of 4, I know is 2. 5 is stuck. So 2 times 2, I'm at minus 4, radical 5. Then you would subtract them if you could, but you can't, because they're not like radicals. One's a radical 2, the other is a radical 5. So 16 should look familiar to something like this. If you were multiplying 2 binomials, you know that you would go through by x, back through by negative 2. Same concept here. We're going to go through by 8. So 8 times 3 is 24. 8 times negative radical 10 would be negative 8 radical 10. Back through by negative radical 10 times 3. 3 is an outsider, so negative 3 radical 10. And then negative radical 10 times negative radical 10. Outside, negative times negative becomes positive. Inside, 10 times 10 is 100. And the square root of 100, I know I can go ahead and make 10. So then let's see here. I can combine like terms. So 24 plus 10 is 34. I've got 2 radical 10, so negative 8 minus 3 would be negative 11 radical 10. Radical 10 is in simplest form because there's no pairs in there. So that is it. Same concept on 17. Going through first by 6 radical 6. So let's see, 6 radical 6 times radical 6. 6 is on the outside. Inside, 6 times 6 is 36. 6 radical 6 times radical 2. Outside is 6. Inside, 6 times 2 is 12. Go back through by -6 radical 2 times radical 6. Outside is -6. Inside radical 2 times 6 is 12. -6 radical 2 times radical 2. Outside is -6. Inside 2 times 2 is 4. So the first things I see is, let's see here, the square root of 36 is 6. The square root of 4 is 2. I've got two groups of radical 12s right there that actually cancel out, right? 6 minus 6, so those are going to cancel. So 6 times 6, I have 36. Minus 6 times 2 is 12. 36 minus 12 is 24. All right, 18, I know that squaring means you multiply by itself, so I've got to do 4 minus radical 5 times 4 minus radical 5. So we go through. 4 times 4 is 16. 4 times negative radical 5 is -4 radical 5. Back through, negative radical 5 times 4 is -4 radical 5. Negative radical 5 times negative radical 5 is positive radical 5. 5 times 5 is 25. So simplifying, I know the square root of 25 is 5. I can combine my radical 5s. So I can combine my 16 plus 5 is 21 minus 8 radical 5. 5 doesn't have any pairs, so that is done. All right, last thing we need to do is throw some variables in there. So we have radical 3k that we're taking through. So radical 3k times radical 12k would be the square root of 36k squared. Radical 3k times -2 radical 15k squared, -2 on the outside. Radical inside, 3 times 15 is 45. K times k squared is k to the power of 3. Simplify what I can. Well, I know the square root of 36 is 6. Square root of k squared is k. So this first one is 6k. Minus 45, I could go 9 and 5. The square root of 9 is 3. 5 is stuck. K cubed, I can make a pair, and I have a leftover. So -2 times 3k would be -6k, square root of 5k on the inside. And the last one we will look at, number 20, we'll go through by radical k times, that is not a k, radical x times radical x squared. Radical x times radical 2 would be plus the square root of 2x. Negative radical 8 times radical x would be negative radical 8x. And negative radical 8 times positive radical 2 would be negative radical 16. So then we clean it up. So let's see here. The square root of x squared is x. 2 and x, there's no pairs. 8, though, is 2 and 4. Square root of 4 is 2. So this 2 is stuck and this x is stuck. Square root of 16 is 4. So I've got x plus the square root of 2x minus 2, the square root of 2x minus 4. So then I see I've got like radicals. I got the square root of 2x and I've got another square root of 2x. So 1 minus 2, I've got x minus 1 would be 1 minus 2. Radical 2x minus 4. So that is day 2 of our radicals.